Alright guys, so with today's set of notes, what we're going to focus on is multi-step equations with distributive property. Before we go into the steps and how to solve, let's look at these examples. So with multi-step equations, what we see is there's a lot to it. We got combining like terms, we got distributive property, and then we also going to have equations that got both. For us today, our main focus is going to be equations that got both, okay? So we're going to be working with equations with both distributive property and combining like terms. Now, with that being said, we're going to move into our steps. And when we look at our steps, there's three things that we have to do for each problem. Okay? The first thing we got to do is we're going to do distributive property. Distributive property only works if you have parentheses. You cannot use distributive property all the time. If you look at a problem and it don't have a set of parentheses, then you can't do distributive property. So that's what we check for first. Okay? After that, we do combine like terms. Remember, you can only combine like terms if you have something that has the same variable or you have constants that don't have a variable behind it. And the last thing we're going to be doing when we solve these problems is we're going to be simplifying the equation by undoing the operation, meaning doing the opposite of what is left after we distribute and combine like terms. Okay, so let's look at our first example. In our first example, what I want us to look for every time is parentheses. That's the first thing we look for. Like this one do have a set of parentheses because it do. What we have is distributive property. And distributive property states that we're going to take the number that's right outside or in front of the set of parentheses and we're going to be multiplying every time. Okay? So like this 3 is on the outside of that set of parentheses, I'm going to take and distribute that 3 to everything on the inside. Okay? So what that means is I'm going to take and do 3 times x. And I'm going to do 3 times negative 2. I'm going to do that first. Okay, that's step 1. So if I do that, that's going to give me 3x. And 3 times negative 2 is going to give me negative 6. And I can bring my equal sign down. Now that my equal sign is gone, not my equal sign, my parentheses are gone, I can take my equal sign and draw my line down the middle. Okay? Now we're undoing the operations because I don't see anything that's considered to be a like term. Okay, everything is by itself. So that means for me to undo, I'm going to start with my constant, the mean, the one without the variable, and I'm going to do the opposite. It says negative 6, so the opposite has to be positive 6. So when I put my plus 6 on both sides, what happens is the negative 6, positive 6 goes away because it's 0. Okay, I can bring down 3x. And then we got 18 plus 6, which is 24. Okay? And then I'm going to take that and divide by 3. Because to undo 3x, which means multiply, you're going to have to divide. So that's going to leave me with x is equal to 8. Okay? So the next example with this one, same thing. First thing we look for, our eye should be looking for is parentheses, which we do have a set of parentheses. And once we notice that, the next thing we see is what's on the outside of that. And what's on the outside is a negative 3x. A negative 3. Excuse me. So with that negative 3 being right there on the outside, we're going to distribute it. And what that means is that we got to take negative 3 and times it to 6. And we got to take negative 3 and times it to negative 2x. That's the first thing we got to do. So negative 3 times 6 is going to give me a negative 18. Okay. Negative 3 times a negative 2 is going to give me a positive 6x. Okay. And what I didn't use yet was that 3x out front. Nor did I use that 27. Okay. Now that distributive property has been taken care of, I can draw me a line down my equal sign. Okay. Once I do that, I look for like terms. Things that are considered to be like terms in this problem is, do I have 2 sets of x represented, or do I have 2 numbers without a variable showing on the same side of the equal sign? In this case, I got 2 x's. So I got 3x and a positive 6x. Signs are the same. Okay, so that's a positive 3, positive 6. So that means I add them together. That's going to give me 9x. Negative 18 didn't have anything to match, so I bring it down. Nor did 27, so I bring it down. Distributive property is taken care of, so now what I work with is undoing the operations that are given. I look for my constant first, 18. It's a negative 18, so that means I got to add 18. So if I add 18 on both sides, the double 18s go away. 27 plus 18 is going to give me 45. And I can bring down my 9x. Now 9x means multiply. Got to divide to get rid of it. So when I take 9x, I get x by itself, divided by 9. And then I take 45 and divide it by 9, I get 5. So the value of x for this one is 5. Alright, so we just completed 2 examples of how to solve an equation with distributive property.